Hi, today we're going to be talking about reasons for trends, and that is basically the reason why Coulombic attraction works the way it is, and some additional information. So first we have, as you move down a group, additional energy levels are added, making the electrons further from the nucleus. When additional energy levels are added, the atomic radius increases as the electrons move farther and farther away. So this makes sense since you have a nucleus in the center and you have electrons around it. Now, the more the energy levels means the bigger the atom, which means the bigger the atomic radius. And our second thing, atomic radius is basically how big the atom is. Now, our second one is the electron shielding occurs when the inner electrons protect the outer electron from the full attractive force of the positively charged nucleus. So this is a really important keyword that on AP Chemistry you would want to include it. On your answer explanation, you will want to include electron shielding and define it. Make sure you define these vocabulary terms because you can't just put a word on there and they need to know. You need to show them that you know what it means. So electron shielding is basically you have one atom in the center. Now you have one layer of electrons around it. Now if you have more layer, the first layer of electrons is gonna prevent the second layer from the full attractive force of the nucleus. So if you have to explain why carbon has a bigger has a stronger Coulombic attraction than silicon, you would say because silicon has an extra layer of electron shielding that prevents the outermost electrons from getting the full attractive force of the nucleus. Now, our third one is that as you move across a period, the effective nuclear charge increases because you added more protons. Additional protons increase positive charge within the nucleus, but the electron shielding stays the same, which results in the electrons being pulled more tightly. So as you go across the period, the electron shielding did not change since it's the same number of layers of electrons. But with more protons, that means it has a stronger pull, and then the key word here is effective nuclear charge. So that's the fancy word of saying the pull. Now, the effective nuclear charge is another word that you want to include on your answer explanations and on the AP Chemistry exam. Now, with more protons means more effective nuclear charge, which means stronger pull, which means smaller atomic radius. Next, we have atomic radius. All right, let me explain this real quick. Size of a neutral atom. As you go down the periodic table, the atomic radius increases. As you go across a period, the atomic radius decreases. Alright, now this makes sense because as you go down the periodic table, there's more energy levels, which makes it bigger. And as you go across, as we just said, there's more protons, which makes it smaller. Alright, now we're going to talk about ionization energy. Atomic radius is also important, so I'm going to keep that highlighted as well. Ionization energy, another important vocabulary term. Now, ionization energy is amount of energy needed to remove an electron from an atom. Decrease as you go down and increase as you go side to side on the periodic table. So here's how it works. Ionization energy is directly related to the effective nuclear charge. So ionization energy is like, think of it as pulling an electron away from its atom. Now, if you have a very big atom, that means the electrons are very far away, and which means it has a very big atomic radius. Big atomic radius means small effective nuclear charge. Now, with a small effective nuclear charge, the ionization needed will be very small, since it's going to be very easy to pull something away. Now, if you have a very tightly packed atom, that means it has a greater effective nuclear charge, which results in smaller atomic radius. Now, it's going to be much more difficult to pull an atom away from an atom that has a strong nuclear charge, which is why the ionization energy ionization energy for the atom will also be stronger as well. And now, as you can see, it decreases as you go down and increases as you go from side to side. So, think of this as a periodic table. As you go down, it decreases as you go down and increases as you go side. Alright, now next we have first ionization energy and second ionization energy. Now, first ionization energy is the energy needed to remove the outermost electron from an atom. And then the second ionization is basically the same, except after that. First ionization energy is pulling away the outermost, and then after you remove all the valence electrons, it goes layer by layer. So if an element has 5 valence electrons, first IVE will be the one of the valence electrons, second IE will be one of the valence electrons, and so on until you get to the 6th IE. Then that will be the second layer of electrons, because all the other electrons have already been removed. Alright, now electron affinity is the change in energy when a neutral atom gains an electron. And now electronegativity is how much an atom attracts electrons. Now, electronegativity decreases as you go down the periodic table and it increases as you go to the right. So basically, the top right has the strongest electronegativity and the bottom right has the least. Now, electronegativity is basically how much an electron wants to keep its atoms. Now, noble gases will have the highest electronegativity. Oh no, noble gases will not have electronegativity because they have a full shell. And here's the same. No, noble gases have no electronegativity. And that means the top right, which is fluorine, is the most electronegative element and is least willing to share electrons. Now, this has been quite a long video, and I'm going to quickly write the formulas for electron affinity and ionization. So ionization formula is X, which is the element, plus ionization energy, resulting the cation plus an electron, the cation of the element. Now, electron affinity is X, which is the element, plus electron makes an anion. And this is a very long video, and I hope that this video helped. If you have any questions, leave them in the comments, and I'll try to answer as many as I can. Thank you for watching.